Okay, you should be good. Sorry about that.
No worries, thank you. So Antonio will be talking about their work integrating the cat's effect type level stack with the Linux kernel API IOUing. Yes. Okay, go ahead.
Perfect. So hello everyone, my name is Antonio. I'm a student at EPFL, and this year I had the opportunity to participate in the Google Summer of Code. So for those unfamiliar, the Google Summer of Code is a initiative by Google to encourage students to participate in open source development. And I participated under the Scala Center, which is a non-profit organization backing the Scala language, and the type level, which is a community of Scala developers focused on building libraries for pure functional programming. And during my project, I work on some of these libraries, particularly in CatFX and FS2. So to give you a little bit of background, CatFX is a major type level library that provides a multi-threaded runtime for high-performance I/O in Scala, and it's inspired by the efficiency of event loop architecture like the one in Node.js, where application tasks and I/O are managed from a single thread. However, CatFX takes this a step further by introducing a multi-threaded event loop, allowing workers to efficiently share and also steal tasks. And on the other hand, we have FS2, which is a powerful library for constructing and manipulating a stream of data in a pure functional way. And there are many libraries in the type level ecosystem that are built on top of these two, such as HTTP4S, Scan, Ridiculous, Lepus, and many, many more. So let me introduce you to the key component of the project, which is the IOUring. So the IOUring is a Linux kernel API that was introduced in the version 5.1 for efficient system calls, such as for reading and writing data on network sockets. And the main idea is that instead of making a function call and waiting for a result, you add operation to the submission queue, which is here on the left, and at some point the kernel will handle them. And meanwhile, you pull the completion queue, which is here on the right, for the results of the completed operations. So this allows an application runtime to coordinate with the system kernel with very low overhead. So in summary, we are batching operations, and therefore we minimize the number of syscalls that we need to use. So the first goal of the project was to define a polling system based on this IOUring to integrate it to CatFX. And since IOUring is native code, we decided to use the native implementation of the IOUring in Java, which was another Google Summer of Code project. And we also defined this Uring API, which is composed of these two methods, the call and bracket. And the implementation of many of these methods are very interesting and also very tricky. But unfortunately, we don't have time to cover all of them, but I will try to give you a general overview of how it works. So here we have the call method that depends on the execute function, which is right here. And first of all, we are going to access one of the ring, which is going to be in one of our threads. And the ring will register the callback of this asynchronous function, and it will give us an ID, which is a short value. And then we are going to enqueue this operation that we want to execute in the submission queue, including this ID. So to show you this with this diagram, basically this operation will traverse the kernel, including this ID. And at some point, it will go to the completion queue. And once we are here in this completion queue, we will have two things. The first is the result of the operation. And the second one is the ID that is linked to the original callback. So what we're going to do is use the ID to retrieve the callback and then return the callback with the result of the operation. And there are a lot of tricky and interesting things that happen here and can happen. And one of them is cancellation. We know that CatFX handles cancellation for us, right? So let's take a quick look to cancellation. So when we try to cancel an operation, we have two main possibilities. So let's explore first the happy path. So let's assume that we want to cancel an operation, and we try to do it from one ring that is in one thread, which is actually the same ring and the same thread that sent the operation that we want to cancel. If that's the case, we simply have to enqueue this async cancellation operation in the submission queue. And if the operation is still in the submission queue, it will be removed. And if it is in the kernel or in the completion queue, we will just remove the result from the completion queue to avoid wasting resources handling this result. And the other path is that we try to cancel an operation that was sent from a different ring, right? So we are in a ring which is different from the one that set the operation. So we are going, what we did to solve this problem is that we are going to have a concurrent queue in each of these rings, and we will add the operation that we want to cancel in this queue. And this is actually the oldest scenario where we need synchronization. So when we tell to the ring the operation that we want to cancel, we have to wake up or interrupt the thread because it might be blocking. And by the way, the wake up method or the interruption is by itself another interesting and very tricky method. So when it wakes up, it will pull, and one of the first things that this will do is to check this queue. And once we are here, we are pretty much in the happy path again because we are trying to cancel an operation, but we are already in the right thread and the right ring that originally sent this operation. So we just need to enqueue the async cancellation from the happy path, and we are basically done. So this was the first part of the project, and then the second part was to implement the sockets using the urine pooling system. And this part of the project was more straightforward, and I'm running a little bit out of time, so I will keep this one short. So here we have the TCP socket implementation using the ring. And if we want, for example, to read, we just need to prepare our buffer, and then we will call the urine main API and with the buffer, and at some point we will have our result. And the write is also very similar. We are going to prepare our buffer, and we will call the urine API with the send operation. So to show you the result of the project, we published a pre-release of our work, and in less than 24 hours, a community member, so thanks to Joel, he benchmarked an HTTP Ember server with the new runtime and reported a 314% performance improvement. And note that we didn't change a single line of code in the Ember server, so the changes were completely transparent. So to give you a little bit of background, Joel used a 24-thread CPU, and the server responds to requests with a simple hello world. And we were able to go from 121,000 requests per second to more than 400,000 requests per second, which is really, really impressive. So here, once again, we denied that functional programming makes the code slow, as we showed that the real bottleneck was not the functional side, but the runtime and the networking. So the question is, what's next with this pooling system? So we really want to make the pooling system usable in production, and for that we have already defined the next steps. So first of all, we want to remove the current dependency on native to interact with the IO urine, and we are exploring several options to work directly with native code, like using GNR or even using the foreign function that are introduced in the Java 21. And the second thing is that we want to offer a kind of all-in-one solution. So if your system allows to use the IO urine pooling system, you will be able to take advantage of this performance. But if not, you will automatically fall back to the next best pooling system available in your system. And to achieve this, we are working on other pooling systems. For example, here we have the ePool pooling system that one of the members of the type level community has been working on. So just to conclude, I really want to encourage any students or person that is learning Scala to take a look at this Summer of Code, because it's really a unique experience and a unique opportunity to learn Scala and to start open source development and be part of a community. So just to conclude, I would like to say thank you to my mentors, Arman and Daniel. Thank you to the type level community for welcoming me and helping me during this journey, to the Scala Center for the amazing work that they do for the Scala community, and many thanks to all of you guys for creating and being part of this amazing community. So thank you very much.
questions? So yeah, another really, really impressive summer project. IOU ring is very complicated. Cats effect MST very complicated. Shipped working code. Joel went and benchmark, he didn't come back and say crashed and say it crashed on the load. He said it was 3 times faster. So if anybody was, by the way, at the type level panel, I think it was like one of the last questions was like, what's next for type level? And this is one of the things that Daniel mentioned, by the way, was that building on building on these results, these very promising results. This is like one of the major next steps for type level as a whole. And so like we were looking at Ember, but many other type level projects will benefit a lot from this work. For example, Skunk, Ridiculous, which is a Redis client. The new Hotel4S stuff, we've been working on open telemetry, pure Scala backends that will be running on Ember. Yeah, so this is something that will have like a lot of ripple effect. Even Hieu's WebSocket project, we actually were able to run it also on this new IOU ring stuff. So Hieu actually ended up building maybe the fastest WebSocket project, fastest WebSocket client on the JVM because he built it on the type level stack. Yeah. So, any questions? Anything in Discord? Okay. Maybe we'll, oh, I see people are grumpy that I'm taking up so much stage time. Okay. Very nice work, Antonio. Thank you so much for being here.
Thank you very much.
Sharing it. Yeah.
Thank you very much. Goodbye.
Okay. Next is, I don't think, Noel, do you know if Danylo was able, I don't know if Noel's still around actually, but this, I found out today that actually Noel Summer of Code student is, yeah, Noel, do you know if Danylo is around? He sent a video, but I guess he probably wasn't going to be able to make it. So let's see if I can get his video up. Okay, great. Well, I wasn't sure. Danylo had mentioned something about maybe being some. Okay, so I was told to put the video up. I do something. I set it as a background. I feel like I'm going to need more instructions then. Let me
So to the on the left hand side, there is a play button that you should see that says add video to background.
On the left hand side, there is a play button.
Do you not see that? If not, toss me the URL and I will put it up there.
Yeah, it might just be easier to do that.
Okay, put it into the speakers channel and I will deal with that.
Okay.
Okay.
Yeah, so it was really cool to hear that actually this project that Danylo worked on is feeding into what Noel was just talking about before, the Scala bridge. I did not know that till now. So that's yeah, I'm excited to see the presentation.
Hang on just a second. That is not quite right. Just having copy paste difficulties here. All right, and now I think we step off the stage and hopefully that will be available for people to watch.
Hello everyone, my name is Danylo and I was a Google Summer of Code student at Scala Center this summer. I worked on a data visualization library called Chart-Reuse, and I'm excited to be here today to talk about the project and my experience. I hope you will find it interesting. Let's begin. Currently, I'm a student at Kharkiv National University of Radio Electronics in Ukraine. My major is computer science. Google Summer of Code is my only experience as for now, and also I'm interested in cryptography and data structures and algorithms. So, Chart-Reuse is a data visualization library that builds on Doodle. It provides a functional and compositional interface to quickly assemble visualizations from small and reusable pieces. That's what we call composition, and actually it's the main philosophy of Doodle, which is a library for compositional vector graphics created by my mentor, Noel Welsh. Doodle lets you create really awesome graphics in Scala. I recommend you to check it out if you like creative coding. I would like to take this opportunity to thank my mentor. Noel played a crucial role in shaping the direction of this project, providing insightful feedback on my work and helping me navigate through all the challenges. So once again, thank you, Noel. Now, let's talk about some of the core concepts of chart reuse. As I said, chart reuse is built around the idea of composition, which means constructing bigger things out of smaller things. In the case of chart reuse, this means a plot is constructed from layers. A layer combines data and a layout, and so on. Each component is reusable in different situations. So you can add, for example, the same data to different layers in the same plot, if you want. As you can see, the layer uses data. And what is great about it is that chart reuse can work with just about any collection class. So it probably doesn't matter how you store your data. You just need to implement a function that will convert your data to the XY coordinates. A layout determines how data is mapped to graphical output. It's a trait that requires its subclasses to implement a draw method. At the moment, we have line, curve, and scatter layouts. The layout trait also has some convenience methods. By convenience methods, I mean methods to convert a layout to a layer or even to a ready-to-use plot. Here you can see a curve class declaration as an example. So, how to create and draw a plot? First, you need some data. Most likely, you will have some real data, but for this demonstration, we will create some simple fake data. Now we have data, we can create a plot. The simplest way to create a plot is to start with the layout. We will use a scatter for this. As I said, we build plots using layers. So we need to create a layer using our data and the layout. But using one of the convenience methods of a layout, we can skip this process and directly convert our layout to a plot. Yeah, we have implicits that can convert iterables to data, so you can just use lists and so on while working with data. Next, we need to convert a plot to a doodle picture using the draw method, to which we pass the size of the output. Then we can render the picture in the usual way for Doodle, which depends on the backend. In this example, we use the Java 2D backend. Here's the result. Chart use is designed to be really easy to use. It should be straightforward to create basic visualizations and possible to create complex ones. Here's what I mean by complex visualizations. It has a lot of layers, where each line is a separate layer. It has minor ticks, it has a grid. Also, it uses custom theming. Theming is another concept that controls colors, fills, and some other aspects of the visual appearance of a plot. But it's a pretty big thing to put it into this presentation, so check out the documentation of chart reuse if you would like to know more. Here is a couple of other examples. You can see it's possible to add legends, just like in the first plot, and annotations, like in the second one. There are actually multiple types of annotations. You are not forced to use arrows, and the text position can be adjusted as you want. The Google Summer of Code was pretty challenging. I had no prior experience with Scala and functional programming at all. I have worked with many languages like Java, Python, Golang, but not Scala. And I think this is what helped me to boost my skills the most. As I had some gaps, I had to work more. It made me realize that the desire to achieve something is sometimes more important than hard skills. People like our mentors are always there to help, and with them, nothing is really impossible. You can find more information about the project in my final report. Just scan the respective QR code. There are also links to the documentation and my LinkedIn, where you can connect with me. That's it. Thank you. Hello everyone. My name is Danylo and I was a Google Summer of Code student at Scala.
Okay. If there's questions for this one, maybe Noel can take them. Do you want to come up on stage, say anything, Noel? Let's see. I think raise your hand. Somebody will.
Hey, I don't have anything particular to say other than Danylo was a great student, and Google Summer of Code feels like a very worthwhile thing to me. So yeah, consider getting involved if you have the opportunity.
I actually have a question. So I didn't realize until today that this was feeding into the Scala Bridge. Can you talk about that? Like, is that how the project was originally born to be part of Scala Bridge? Did that come along the way?
It's a little bit of both, to be honest. So the idea is in the data science section, we want to do some visualization of data. So we want to have a library that makes that easier to do. The students will be able to do some visualization themselves, but they're quickly at the point where it just becomes too much work to create axes and all this kind of stuff. So having the library there is cool. But I've always wanted to extend Doodle with visualization. So it's kind of been a long-term goal just to make it a little bit more relevant to what most people do than the creative coding aspect, which is fun, but doesn't get a huge amount of industry use. So just trying to hit a number of different goals really with the project. Create something I think is generally useful to the Scala community because we don't have this tool as far as I know. It runs on JVM and JavaScript. Produce something for Scala Bridge and Scratch and Itch.
Thank you. I think that was all the students who were able to join us today to present. There were actually 7 projects total. Let me see if I have a list of all of them. Yes. So yeah, so we saw the WebSocket client, we saw IOUing, and we saw the plotting API just now, and then yeah, there were actually 4 more projects. One of them was by Akseli. This one was working on a template for sort of building full stack Scala apps. I think it was for with like Scala JS and the Scala backend, the JVM backend. So that was upgrading it to Scala 3. There were 2 projects, unfortunately, I cannot comment much on because they were doing like really clever compiler stuff. One of them was working on the compiler itself, Dotty, the Scala 3 compiler. So yeah, you get the quote pattern matching. Probably anyone who's done something with macros may have an idea of like, yeah, actually, I've had to fix some code that they quote pattern match. So yes, that sounds good. And then if anyone has played with any of it's like Dotty CPS async, so we've got like Cat's effect CPS or something, any of that async await syntax, there was a project that was working on that as well. And then there was also work on a type levels open telemetry library of Tel4S by, yes. So these were Akseli, Yuito, Olena, and Sherry. So yes, it was a cool cohort. In the last few minutes, I'm going to talk about, I didn't feel like making another presentation, but fortunately I found that Google gives like some marketing slides for their Summer of Code program. So I'm just going to steal these and see what we'll find in it. So yes, so Summer of Code is a program that's run by Google. And I don't know how many people were generally aware of it. I was aware of it even when it's generally been targeted at students, although in recent years it seems like it's become more flexible. I knew about it as a student, but for some reason I never did it. So this was my first year involved. as a mentor. The Scala Center has actually been involved in the program for several years now, which turns out to be important because a big part of it is sort of building a reputation with Google and demonstrating that you can sort of successfully mentor students and have successful outcomes. Yes, so yes, and the whole big idea of like the nutshell idea of Google Summer of Code is to pay students a small stipend so that they can work on open source projects over their summer, and as well as get access to mentorship and get involved with the open source communities. And so we've been talking a lot about open source today and yesterday, but a lot of the Scala ecosystem, including like the Scala compiler and a lot of the major libraries like type level libraries, these are developed openly. And so that means, you know, a couple things. It means that the code is freely available for people to look at and change. And it also means that we're open to accepting contributions and collaborations from basically anyone. So yes, it is very, very, very community oriented. So yes, and Google Summer of Code is internships. It's basically funded internships for students to get to join us and work on these communities, participate in our communities and work on these projects over the summer. So let's see. Anything else interesting? Oh yeah, so there are different kinds of projects, and is in length of the projects. There's like medium length projects and there's some bigger projects. So there's some flexibility in also like the size of the project and like the timing, whether it's going to be over, I think it's like between like 10 to 20 to 12 to 22 weeks or something. There's a lot of flexibility built into the program, but overall the goal is really focused on people, bringing in new people that are new to open source, people that are new to the community. That's why it's generally like focused on students. That is very much the goal of the program, to try and bring in new people into our communities, show them the ropes, get them involved with contributing, and with the idea that even after the program ends, they will continue to be involved. And I'm happy to say that is exactly what's happened. Like the fact that our students came today and they were able to present, this is exactly the continued involvement, which I think is fantastic. Yeah, I'm ahead of the slides. Yes, goals of the program. Yes. So, and yeah, there's so much other great things, you know, you like obviously being involved in open source is great to just learn how things work. It's a very, very real experience of like how to work with GitHub, how to make pull requests, how to discuss with people and take PR feedback, and sometimes deal with the fact that, you know, projects are hard and, you know, you've got maybe changing constraints and things. So, oh yeah, so there's a timeline. So we first found about, and I should say actually, so the way I participated in like these type level projects, and Noah participated, the way that we participated was because actually the Scala Center has been participating with Google Summer of Code, and they were their organization. It was Anatoly and Yuito. Anatoly from the Scala Center. Yuito's a PhD student at EPFL. They were generously administering the program on behalf of all of Scala, basically, and they made a call for mentors. I hope when they do this again next year, some people here might be interested because it's obviously very rewarding. So that happened, gosh, I don't remember when that happened, maybe the beginning of the year or something. So they may, yes, there's a call for mentors from the Scala Center, and that's how we got involved originally. And so the first step is for us to sort of carve out some project ideas and make a list of these for potential contributors. And then these get listed, and then it's just about advertising. And I think this is one of the tricky things. I was thinking about it too with Noel's like Scala Bridge talk. It's really hard sometimes to be able to reach students and things. But we were lucky this year, and we got some great applications. So the application process for the students is actually, it's very interactive. The idea is that they don't just submit an application. They should actually, they write a proposal, which is hopefully sort of unique rather than sort of regurgitating the project. They hopefully sort of put together a unique proposal about the project that they're interested in working on and their own take. It doesn't have to be one of the project ideas that you've listed. It can be something that they talk about with you, you know, if they've joined your community and already started talking. We had some really interesting project proposals that came out this year that were just through discussions. Unfortunately, not all of them got funded, but there was a really cool one, like doing a cats effect machine learning runtime and stuff, and maybe next year or something. So there's actually the application process is like supposed to be a lot of interaction. Again, it's very much about the interaction and getting involved with the community, which is really great. And then so yes, once the students, so the contributors, the potential students, potential contributors, they work on these proposals, they get feedback from their potential mentors and the community, and then it does eventually get submitted, and then we rank those within the Scala Center within we were ranking them internally, and then those get submitted to Google, and Google decides how many of those it's able to fund for us. Yeah, and then yeah, after that, there's just, after the projects are selected, there's like a few different phases of, before the official coding starts, there's still very encouraged periods of like community bonding period where it's just about trying to get, encouraging your contributors to get involved with the community and things like that. So it is actually very, very community focused. Yes. And yes, I hope this, I was reaching out, if there's people here interested in mentoring, I hope that there's actually people here who might be interested in, are new to Scala, and new to open source, and maybe still in university. Please, if you're interested, like think about doing Summer of Code next year. We'd love to have you. Another important part of the process is there are evaluations, and it's important sort of checkpoints at which point the students get paid their stipends as well. So there's 2 evaluations. There's a midterm evaluation, and then there's a final evaluation. It's just a good checkpoint. Really, the main idea is that the mentors and the students are working together, week to week on their projects. So the evaluation shouldn't really be surprises. They're just important. They're just formal checkpoints along the way of the project. But really, most of the feedback should be happening, ideally, even pretty openly, because that's how open source works. So. And then let's see, eligibility stuff. And oh yeah, he was like the program. Oh yes, I was remembering correctly. It was like opening at the beginning of the year. And things basically just wrapped up. Some of the extended projects would have been still wrapping up, I guess. And yeah, a lot of people are involved. So strongly encourage people to get involved with doing Summer of Code if this is something you're interested in. Great for students, great for mentors. Great for open source community. So one of the things that surprised me when we got involved this year was we actually got a lot of interest from people that weren't necessarily the right fit for going through the Summer of Code program, whether they just didn't have enough free time in the summer, like, they're not a student with a summer free to work on, or they're too experienced per what, they're not a beginner in the way like Google Summer of Code is really focused on them. They're already working as like a professional engineer, a software engineer, but they want to be more involved in open source. Anyway, the interesting thing was that when we made this very deliberate call out, we said, like, we have these projects that we think would be good to work on. We are looking for people who want to contribute to open. We got a lot of responses, and even though a lot of these people didn't go on to become official Google Summer of Code contributors, they ended up becoming really meaningful contributors to our ecosystem. So like even one of those, some of the follow-up work that Antonio was sharing about making an ePoll-based IO polling system for Cats Effect, that the contributor working at Moto Yuki was somebody that was actually interested got interested in the Danylo ecosystem and reached out because they saw this call for Google Summer of Code contributors. So at least for me, this was really interesting. Like suddenly there were all these people that were interested, and the thing is, they were there all along. So it's really interesting how sometimes it helps to maybe just make that more deliberate and more formal call for contributors to our ecosystems, because clearly there are people interested in. Again, they have made really significant contributions to across type level projects, at least I was involved in. So I think that's fantastic. Okay, I think people are going to be sick of me by now. So yes, one last round of applause for all the amazing Summer of Code contributors, the students, and thank you for all the mentors, and yes, the administrators at Scala Center for running it.
Thank you, Arman, and thank you to all the folks involved with Summer of Code. This is really great stuff, and it's great to see the ecosystem evolving and new people coming into it. So we'll now take a break, come back in about 15 minutes, and we will have a talk on the power of Scala with large language models.